There we go. We're going to talk about how to solve trig equations. So this is our goal. How to solve trig equations. So we're going to go over a couple of examples to understand the behavior of trig equations and what are we talking about. For example, suppose I ask you to solve the following equations. I ask you to solve sine x is equal to 1/2 is equal to a half. Well, what do I mean by that? On the left-hand side, I have a function. On the right-hand side, I set it equal to constant value. Let us take a look at decimals. Let us try to visualize this first. Okay, let us grab sine function, x, and then graph y equals to 1/2 or a half. Okay, take a look at the graph, everybody. What do we see here? We see that this is our sine function. Well, there is no doubt there. This red graph is the sine graph. This blue line, flat line, is y equals to a half. We're looking for the points of intersection between the sine function and this horizontal line. Well, okay. If I go to the left, go to the right, I see there are a lot of points like this. Am I right? It's not just one point of intersection. There are a lot of them. And our job is to represent these points where sine hits or cross line y equals to a half. As you can see, if I continue to the left, to the right, these two graphs, they both continue, both sides. And you see a lot of points of intersections between these two graphs. So let's go back to the board. Very well. So what are you going to do? You're going to first try to limit yourself to an interval. Let us limit ourselves to the interval 0 to 2 pi. Okay. Means that I'm just working on unit circle rotating once, or just looking at the sign between 0 to 2 pi. On this interval, sine x is a half if x is equal to pi/6 and sine x is equal to a half if x is equal to, well, 5 pi/6. 5 pi/6. Okay, just let us go back to our graph. Remember these from the unit circle. When x is pi/6, sine of pi/6 is a half, and when x is equal to 5 pi/6, the sine is also a half. But it is just limited to this interval, one rotation, one period. But remember that we are not limiting the domain of the sine in general in this example. This is the strategy that we're using to find some of the solutions. And since our sine function is periodic function, we can just add 2 pi to pi/6 2 pi to 5 pi over 6 and continue this process. Let's take a look at our graph again. Very good. So again, we are looking for the points of intersection between sine and this line. On one period, as you remember, sine is equal to a half. The y value of sine is equal to a half if x is pi over 6. Also, if x is equal to 5 pi over 6. Okay, forget about the second point. This is pi over 6. What is the next point? 13 pi over 6. What's the connection between pi over 6 and 13 pi over 6? If I add 2 pi to pi over 6, I get 13 pi over 6. So let's go back to the board. So far, we saw that if I add 2 pi to pi over 6, if I take the common denominator between these two, pi over 6 plus 2 pi times 6 divided by 6, pi over 6 plus 12 pi over 6, or 13 pi over 6 is another point of intersection between sine and a half. Okay, we just learned this. Just move this a little bit up. Pi over 6 plus 2 pi, pi over 6 plus 2 pi times 6 divided by 6, which is pi over 6 plus 12 pi over 6, which is 13 pi over 6. 13 pi over 6. So, well, this is the next value, the next point that we saw. And we saw that the connection between pi over 6 and 13 pi over 6 is 1 period. Okay, now let us go back to the graph. What is the next point? Okay, so I had pi over 6, I have 13 pi over 6, I have 25 pi over 6. Okay, what's the connection between 25 pi over 6 and 13 pi over 6? Take a look at this. I have now, the next point is 25 pi over 6. So if I add 13 pi over 6 and 2 pi, I get 13 pi over 6 plus 2 pi times 6 divided by 6. Well, here I get 13 pi over 6 plus 12 pi over 6, which is 25 pi over 6. Okay, do you see the pattern? By adding 2 pi to previous x value, I get the next x value. Okay, that makes sense. So far, if I just write pi over 6 plus 2k pi, I get these points, 13 pi over 6, 2 pi over 6, and so on. What is this? This is actually just pi over 6 plus 4 pi, all right? 2 times the period that you have. Okay, you can do the same thing for 5 pi over 6, 5 pi over 6. So you have 5 pi over 6, and if you add 2 pi to 5 pi over 6, you're going to get to the next point. So plus 2k pi. What is k? K is an integer, a signed number. So the solution set is written in two formats. X is pi over 6 plus 2k pi, and also x is equal to 5 pi over 6 plus 2k pi. K is an integer. Very good. So let's take a look at another example. So far we saw that sine x is equal to a half. What did we do? We just restrict ourselves to a very small interval at a period of sine function, and then we found two angles that make sine to be a half. Then what did we do? We added 2k pi to pi over 6, 2k pi to 5 pi over 6 to find the rest of the points, the rest of the numbers. Now let's make it more interesting. Now suppose I ask you to find the solutions of the following equation. So here we have sine x equals to, let's write a negative number, negative square root of 2 divided by 2. The very first step is to graph this guy. What's the graph like? Okay, let's go back to our Desmos. Here now you have negative square root of 2, and then I'm going to divide that by. Okay, guys, take a look at it. I have my sine, this is a sine function, and then I have a horizontal line, which is y equals to negative square root of 2 divided by 2. This is a negative line, so it's going to be below the x-axis. So what are we looking for? We're looking for all of these intersections between the sine function and this horizontal line. We want to know what is the best representative for these points. So just minimize this. I'm looking for these points. I want to find a way to write this in short and compact form. It's impossible to list them all. If we do not have any space, how do you list these all? If I ask you on the exam, okay, list all points of intersection with sine and this horizontal line, your answer should be, hey, there are a lot of points, we cannot list them all. So what's the remedy for that? The remedy is, well, we're going to just restrict ourselves to a very small period between 0 and 2 pi, all right? And find two basic points where the graph hits this horizontal line. As you can see, one of them is 5 pi over 4. The other one is 7 pi over 4, or going back from the unit circle that we memorize these, they have the following: 5 pi over 4 and 7 pi over 4. So let us go back to the board. This is my y value, and this is my y value. I'm setting these two functions equal to each other. F of x equals to g of x. My f of x is a trig function. My g of x is a constant function. Negative square root of 2 divided by 2 is just a number, and we call it a constant function. We are trying to solve this equation. It means that we are trying to find all intersections between these two functions. The very first function is sine function. The second function is a constant function. And as we saw the graph, there are a lot of intersections between them. So what's our strategy? Our strategy is to just limit ourselves, restrict ourselves to a very small interval. Let us find the solutions of this equation on a very small interval. What interval? 0 to 2 pi. Okay, I did that. So on this interval, sine x is negative square root of 2 divided by 2 when x is equal to, I just saw that, 5 pi over 4, or I memorized this from the unit circle. On this interval, on the same interval, sine x the y value of sine is negative square root of 2 divided by 2 when x is equal to 7 pi over 4. Two basic values. Then we know that the sine function is just a periodic function. So we're going to just add 2k pi to each one of these. So the solution set of sine x equals to negative square root of 2 divided by 2 must be written as x is equal to 5 pi over 4, copy down whatever you found, plus 2k pi. And you need to add both of these. And x is equal to 7 pi over 4 plus 2k pi. And k is an integer. You have all of these solutions listed here for you. You do not have to list them separately. You can just represent them in this nice compact form. X is 5 pi over 4 plus the rest of the angles coming from the rest of the repetition, because sine is a periodic function on the rest of the periods. And also x is 7 pi over 4 plus the rest of the angles values on the other periodic part of sine function. Take a look at your graph. So we found 5 pi over 4. What's the relation between 5 pi over 4 and the next angle? This is 5 pi over 4 plus 2 pi. What about this angle? This is 5 pi over 4 plus 4 pi, 2 times 2 pi, and so. Very well. Now let's work on some tangent equations. So question says, solve the following. Okay. Solve. Here I'm going to give you tangent of x equals to square root of 3 divided by 3. And I'm going to give you another example so you can see this side by side. Solve tangent x equals to negative square root of 3 divided by 3. Very good. Okay, let's check each one of these separately. Very good. Let's go to our decimals and here graph tangent of x, not here. And then graph y equals to square root of 3 divided by 3. Very good. So we have the tangent function and we have this constant function. You want to know what are these points? Well, is it possible to list them all? Nope, it's not possible to list them all. But we have a nice method representing these in a compact and shorter version. Guys, remember that the period of tangent is pi. It repeats itself after pi. Okay, perfect. So on one interval, what's the intersection between tangent and this horizontal line? is going to be pi over 6. Okay, so since it repeats itself after pi, we expect the next point to be pi over 6 plus pi, which is 7 pi over 6. So it's going to repeat itself after each pi. 1 pi, 2 pi, 3 pi, 4 pi, and so on. So let's write it down. So since on one period, tangent of x is equal to square root of 3 divided by 3 when x is equal to pi over 6, and the period of tangent is pi. So the solution set is x equals to pi over 6 plus k pi. The period of tangent is pi, so we just multiply pi by k, and k is an integer. Okay. You can plug in different values for your k and check your answers. You can double check these answers with the answers that you got from decimals. If k is equal to 0, x is pi over 6. If k is equal to 1, well, let's see. You get pi over 6 plus 1 pi or pi, which is pi over 6 plus 6 pi over 6, which is 7 pi over 6, and we just verified that on the graph. You can continue this process. If k is equal to 2, you get pi over 6 plus 2 times pi, because k is 2. What do you get? You get pi over 6 plus 2 pi times 6 divided by 6, pi over 6 plus 12 pi over 6, which is 13 pi over 6. Is this the third number on the graph? Let's check. It must be 13 pi over 6, which is 2. And just double check all of these points randomly. But the way that you're going to represent it is in the box. X is pi over 6, the angle in one period, plus k times the period. There you go. What about this guy here? If I were to solve tangent x equals to negative square root of 3 divided by 3, what should I do? I need to look at the tangent and the line negative square root of 3 divided by 3 on decimals to find the angle. Take a look at this. Now I'm going to just multiply this constant by a negative sign. The line jumps to the negative part of y-axis. So as you can see, you have intersection with your tangent here, negative pi over 6, 5 pi over 6. If you were to choose a positive angle, you can work with 5 pi over 6. Okay, so you can write 5 pi over 6. And since tangent repeats itself after pi, you're multiplying pi by a random integer like k. K is an integer. So the same process, since on one period, tangent of x is negative square root of 3 divided by 3, when x is 5 pi over 6, and the period of tangent is pi, so the solution set is in the box as we described before, 5 pi over 6 plus k times pi. Let's go over another example. In this example, I want to make it a little bit more interesting. Suppose I ask you to solve the following equation. Well, what is the equation? The equation says, hey, I have cotangent of x times cosine squared of x equals to 2 cotangent of x. Okay, well, what do I have here? I have cotangent of x, cosine squared of x equals to 2 cotangent of x. What are you going to do? Like what you did before in algebra. Remember that? In algebra, if you are to solve an equation like this, x squared plus 2x plus 1 equals to, for example, 3x, you're going to bring everything to one side and try to apply, for example, factoring method or any other method that you feel comfortable working with. We subtract 3x from both sides, we get x squared minus x plus 1 equal to 0, and then solve by factoring or other methods that we learned. The same process here. You cannot leave 2 cotangent on one side. You cannot just say that, hey, I'm going to cancel out cotangent, and I end up with cosine squared equals to 2. That is wrong. That's a no-no. So let me write it here for you. If you write it that way, you do not get all the solutions. No. Cotangent of x, cosine squared of x equals to cotangent of x. Do not cancel out cotangent. This is a no. Bad. So you need to subtract 2 cotangent of x from both sides. This is your very first step. What do we get? We get cotangent of x times cosine squared of x minus 2 cotangent of x equal to 0. Now, between these two, we're going to factor out cotangent of x. Okay. These two factor cotangent of x. Very good. So we're factoring out cotangent of x. What happens? We get cotangent of x outside parentheses. We get cosine squared of x minus 2 equal to 0. So what's the meaning of that? It means that we end up with 2 equations. We get 2 equations. How? First of all, if a times b is equal to 0, it means that either a is 0 or b is 0. I have a times b equal to 0, so either a is 0 or b is 0. So it means that cotangent of x is equal to 0, or you're dealing with cosine squared of x minus 2 equal to 0. We get 2 equations. Now we have to solve each equation separately. So we need to solve these equations. Well, this equation is super easy to work with. Why is that? If you take a look at this equation, the thing that you have is cosine squared of x equals to 2, or cosine squared of x, if we take square root of both hand sides, is equal to square root of 2. What's the meaning of that? It means that your cosine x is equal to plus minus square root of 2, which is impossible. There is no solution here. Cosine x and these two lines, they never hit each other because the maximum value of cosine is 1, the minimum value is -1. These lines are above cosine function. Let me show you. So suppose you have your cosine function and the second line, y equals to square root of 2. Do you see an intersection between these two? Is there any intersection between cosine function and this horizontal line? No, this horizontal line is above cosine. There is no solution. There is no x value. What about negative square root of 2? This line is below cosine. There is no intersection between them. Okay, when there is no intersection, it means that there is no solution. So that's why we say that cosine squared of x minus 1 minus 2 equal to 0 has no solution, no intersection. I'll put it down, no intersection. So this equation doesn't have any solution for me. This is your conclusion. So this equation has no solution. So we have to move on to the second equation, which is cotangent of x equal to 0. Okay, it's obvious. On one period, cotangent of x is 0 when x is equal to, remember that cotangent was cosine over sine. It is 0 if its numerator is 0. Cosine is 0 when x is equal to pi over 2. Very good. So this is on one period. Therefore, the solution set is pi over 2 plus k times pi. Very good. We found the solution from solving cotangent of x equal to 0. Nice and funny. Okay, let us make it more interesting. So now I'm going to give you this equation. Question says, solve the following. Here you have 2 times sine squared of x plus 3 cosine x minus 3 equal to 0. Okay, remember that last time we started talking about factoring. Remember, I told you you cannot apply factoring because these two are not the same. If you had, for example, a u squared plus bu plus c equal to 0, then you can use factoring, either using quadratic formula or any factoring method that you know, to write this in factor form. But you must have the exact same variable or the exact same function here. What's the remedy for that? First, we need to convert sine squared into cosine squared. Remember that. Sine squared plus cosine squared is always 1. So sine squared is equal to 1 minus cosine squared. Let's use the second one and replace it here. We get 2 times 1 minus cosine squared of x plus 3 times cosine x minus 3 equals to 0. Well, distribute 2 into parentheses. Get 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equal to 0. We have some constants. Let's just combine them. We get negative 2 cosine squared of x plus 3 cosine of x minus 1 equal to 0. Now multiply everything by negative sign. multiply both sides, y, and negative sign, just a negative sign, or -1, whichever you feel comfortable saying. Negative times negative gives you positive. So we get 2 cosine squared of x. Negative times positive 3 gives you -3 cosine x. Negative times negative gives you +1. And negative times 0 is just 0. Well, now I can compare this with a quadratic equation that I saw before. From algebra, I learned how to write this guy in factor form. Well, what you can do, you can either use grouping method or using quadratic formula. You get 2 cosine squared of x minus 2 cosine of x minus cosine x plus 1 equal to 0. So take a look at this. If I factor out 2 cosine, I get 2 cosine of x, and what's left? Cosine x is left, minus 1. But between these two, factor out negative sign, I get cosine x minus 1 equal to 0. Between these two, you can factor out cosine x minus 1, and you're left with 2 cosine x minus 1 equal to 0. Well, we have 2 equations to work with. So now we need to solve these 2 equations separately. Okay, not that bad. Let me write them here. So the very first equation that you have is cosine x minus 1 equal to 0. When you try to solve this, it means that you're going to add 1 to both sides. Isolate your cosine. Cosine x is equal to 1, right? Well, for which value of x cosine is 1? We know that cosine is 1 when x is equal to 0. So solution set is written as 0 plus 2k pi, or just 2k pi, right? So x is 2k pi. Put this in the box. This is the solution for this equation. Now, for the second equation, 2 cosine x minus 1 is equal to 0. Add 1 to both sides, then divide by 2. You get 2 cosine x equals to 1. Now divide by 2. Cosine x is a half. Okay, cosine x is equal to a half at 2 points. At 2 points. If you take a look at your unit circle, hopefully you memorize that by now. X is equal to pi over 3, and also x is equal to 5 pi over 3. So since the period of cosine is 2 pi, you're going to add 2k pi. 2k pi. So let's put this in the box. So these are the solution for this equation. So when you're representing the solution for this equation, x equals to 2k pi, x equals to pi over 3 plus 2k pi, and also x equals to 5 pi over 3 plus 2k pi. You need to list all of these solution sets as the solution for this equation.